Good afternoon, students. I'll start with the class. Okay, so today will be a new topic that will be on higher order parametric functions. Okay, and this will be the last topic in derivatives. So based on, we have already done parametric functions. Okay, now this is just higher order, means first you have to find dy by dx, then extra d square upon dx square. That's why it is called higher. So normally in parametric, we know that there will be two separate functions given to you. One will be x and one will be y. This could be anything in terms of t also. You have noticed the letter could be m also, could be theta, anything. X is equal to sine theta or x is equal to sine t. So generally I've taken it as t. Now first step what we should do, we have to find separately, we have to differentiate x with this function with respect to t. Same way we have to differentiate this also with respect to t. Okay, both separately we have to differentiate. And what is to do? What was dy by dx? This dy upon dt, this answer upon your x answer. So this was not a parametric functions or differentiation which we have done till now. Now higher order means obviously you will have to differentiate it again. Now consider dy by dx is this. Okay, some answer you will get out of it. So you can name it as h. I've used f and g. I just use it as h. Okay, so this was supposed to be the answer. Now what we'll have to do? We want d square y upon dx square, we want the second order. So what it will be is, we want this to be d square y upon dx square. So with respect to x, we will have to differentiate. See, whenever you are differentiating with respect to t, you will get dx upon dt. But now this is x, denominator is x. So what I'll have to do is, remember for higher order parametric, up to here you know. Now next step, this is always fixed, huh? Differentiate with respect to x. First time you did it with respect to t. But second time, since I want it as d square y upon dx square, I'll have to differentiate it with respect to x. So first time with that letter, and second time, no matter even the answer is in terms of t, still you have to differentiate it with respect to x. Okay, as we solve the problems, we'll understand. So this will be d square y upon dx square, because we are differentiating it with respect to x. So then you have to take the derivative with respect to x of this. Okay, and now since this is t, extra you will have to take dt upon dx, because this is letter t and we are differentiating it with respect to x. Those who want can remember this as a formula also. Okay, this will be for high order derivatives. Once we start solving, you will remember this, how to do. But those who prefer studying it as a formula can write like this and keep. Okay, so this is d square y upon dx square will be, take first derivative of this and then extra derivative of t. Okay, so just write this. So these steps you have to remember. First differentiate with respect to t and then with respect to x. The first question, if x is equal to a cos theta, y is equal to a sin theta, prove that y cube d square y upon dx square plus a square is equal to 0. if x is equal to a cos theta, y is equal to a sin theta, prove that y cube d square y upon dx square plus a square will be equal to 0. Okay, so those who know can already start finding at least dy by dx. Parametric functions, you know. If you notice in the answer, this is d square y upon dx square we need. Okay, now don't worry about this. All we have to see is we first want to find this d square y upon dx square. For that, first we'll have to find dy by dx. So normal parametric function has to solve. We have to solve this. So now we have first aim is to find dy by dx. So x is given as a cos theta, y is given as a sin theta. So first what we'll have to find dx upon d theta. Because this is theta, we have to differentiate it with respect to theta. Okay. So what we'll get is dx upon d theta will be equal to, same thing I'm doing now. We have done the similar problems in parametric. So this is a is a coefficient. Derivative of cos theta is nothing but minus sin theta. Okay. And theta is matching. So you don't have to take extra derivative. Now differentiate again beside also. Dy upon d theta will be a cos theta. This is nothing but, this is the answer we get for dx upon d theta. Same way dy upon d theta will be a cos theta. Then find dy by dx. Second answer upon first answer. So dy by dx is nothing but this answer upon first answer. So a cos theta upon a and a will cancel. So what we'll get is minus cot theta. Okay, answer will get as minus cot theta. So this is the first step to find dy by dx. Anybody has doubt? Now you have got dy by dx as how much? Minus cot theta was the answer. Now I want d square y upon dx square. So we need this. So now I told you second step will always be with respect to x, not with respect to theta. Okay. So this is with respect to x. So again, when you differentiate, what will happen? Straight away, this will be d square y upon dx square. Okay. Now, what will be d square y upon dx square? We have to find derivative of this. So derivative of normal derivative you have to find. So cot theta will be what? Minus cos x square theta. This would be actual answer. But now remember this is theta and we are differentiating with respect to x. So never forget to write this extra term d theta extra. How we used to write extra dy by dx? If it was y, normally if this was cot y, okay, what we used to write, derivative of cot y would have been minus cos x square y. Extra what we used to write, dy by dx because this was y and it was not x. Same way, this is theta now. So extra, here is theta and x are not matching. That's why extra d theta upon dx. If you forget this, your entire answer will go wrong. Okay. So till this part, anybody has doubt, please ask. What I've done is just directly differentiated with respect to x. So derivative of cot theta will be minus cos x square theta. And since this is theta, extra d theta upon dx. Now this answer you will always get over here. Look at this box. Okay. So if you see this box, dx upon d theta already you must have found starting. Okay. So dx upon d theta was how much? Minus a sine theta. Now ulta if you make, so what will be d theta upon dx? 1 upon minus a sine theta. Okay. So if you reverse this, this answer will also reverse. So you can mark that equation as 1 and then here you can write from 1 you got. So minus into minus will be cos x square theta into this will be ulta. Okay, this is d theta upon dx and that was dx upon d theta. So always you will get this answer here, reverse and write. Okay, and if you bring this cos 1 upon cos x will become sine square. So if you actually this will become sine cube theta. Cos x if you bring down it will become 1 upon sine square theta and sine square already 2 and 1 will become 3. Okay, so this is your answer. Actually, if you were asked only to find dx, d square y upon dx square, this would be your answer. Okay. So this is called higher order parametric derivative to find d square y upon dx square. And now there's been extra of something which has been asked to prove. So prove that y cube d square y upon dx square plus a square is equal to 0 you have to prove. So just take your left hand side of this. So left hand side is this d square y upon dx square plus a square. Now what is the value of d square y upon dx square? Over here. Okay, so you can substitute y cube also you can substitute. Y you will get in the question itself. Okay, and then show after solving show that the answer is equal to 0. So what is the value of y given in the question only? Starting only it was given. If x is equal to a cos theta, y was a sin theta. So a sin theta cube. What you got the answer is d square upon dx square is a sin cube theta. Okay, plus a square. So next step will be cube. So this will be a cube, sine cube, theta. Cube will belong to both the terms. So cube and cube will cancel. 1a, so a square minus a square plus a square is equal to 0, which is equal to your right hand side. Okay, so whichever question has been given, what you do is first find d square y upon dx square, then substitute all the values, ensure that the answer is coming out to be 0. Anybody who has not understood can ask. Some students are joining up half an hour and all. I don't know what you all will understand also, because starting but you missed out. If x is equal to 80 square, y is equal to 280, prove that x, y, d square y upon dx square plus a is equal to 0. Okay, x and y is given. So start differentiating. Find at least dy by dx. So this is t. So we will have to differentiate with respect to t. This is a coefficient. Okay, so first find dy by dx. If you are struggling with this, at least finding dy by dx means you have not studied parametric functions, which I had done before. So I differentiate this. So dx up with respect to t. Okay, so dx upon dt will be, a will be there only, t square will be 2t. So this answer will be 280. Again differentiate this also with respect to t. dy upon dt will be 2a will be a coefficient, both are numbers. Derivative of t will be 1. Okay, so t and t matching, no need to write extra on dt and all. Okay, not by both the answers. So dy upon dx will be second answer upon first answer. So answer is 1 upon t. Okay. Now if you see in the question, we need d square y upon dx square. So we'll have to differentiate it one more time. So dy upon dx is anyways 1 upon t. Now we want d square y. So I told you second time when you are differentiating, always it will be with respect to x. So this will become d square y upon dx square is equal to derivative of 1 by x is how much? Minus 1 by x square. Same way, 1 upon t derivative will become minus 1 upon t square into this is t and this is x. Extra what? dt upon dx. Okay. And then this answer I told you all where you will find over here. Reverse this answer and put it here. This is dt upon dx. This is dx upon dt. So dt upon dx will be 1 upon 280. If you all want to mark like this, 1, this is equation 1, and then from 1 you get the answer. Later when you are studying, if you want to know from where it came. So d square y upon dx square will be minus 1 upon t square, 1 upon 280. So that will be t cube, no? So this will be your answer. 1 upon 2a t cube. Now I have to this is okay, no? Now I have to prove something. So that will be what has been asked. X y d square y upon dx square. I'm directly taking the left hand side up. Plus a has been asked. So you have to substitute the values and show that the answer is turning
Done.
out to be 0.
In xy, we have to put the value of x and y and multiply that now.
Huh?
In xy, there it is. We have to put value of x and y and then
I'm not
multiply.
able to hear you.
So we have to put the values of x and y and then multiply. No, it is xy.
You have to substitute the value of x and y also.
Yeah,
X will be how much? 80 square.
yeah.
Y
And
will
y
be how
will
much?
be
280.
280. And then
Yes.
multiply.
And then put this value also, all the values.
Yeah, done.
And then somehow they will get cancelled and answer what you'll get is minus a. And then this will be minus a plus a will give you 0. So x in the question is given as 80 square. Okay, y is given as 280 and this is okay, all the values I've substituted, then cancel. T square 1, all 3 will go because 2 and 1 total will become 3. 2 and 2 also will cancel. So what will be left is minus 1 into a will be minus a plus a, which will be equal to 0 and equal to your right hand side. Okay, so anytime it's asked to prove something like that, basically you have to find first d square y upon dx square, take the left hand side, you can substitute and show that it is equal to right hand side. One good thing about this is you know that your answer was correct. If this is turning out to be wrong, something you got by mistake some other answer, this will never end up 0. It will get complicated. Okay, so if you are not getting 0 means something is gone wrong. x is equal to a sec theta, y is equal to a tan cube theta. Find d square y upon dx square at theta is equal to pi by 4. So you can start differentiating. This is tan cube theta, not tan 3. This is cube. This is simple. Straight away, derivative of sec theta you have to write. So answer will be a sec theta tan theta. This you have to assume as like the whole cube. So first it will become 3 tan square theta into extra derivative of tan theta.
dy by dx is equal to 3 sin theta.
So we are differentiating. Now this will be with respect to theta. So dx upon d theta will be, a is anyways coefficient. Derivative of sec theta is sec theta tan theta. So this will be dy upon d theta. A will remain at the side only. Now, if the answer was, if this was simply tan theta, then derivative of tan theta would have been sec square theta. But now there's a cube. So it is same thing like x cube. So derivative of x is 3x square. So same way, this will be 3 tan square theta into extra derivative of tan theta. That would be sec square theta. Okay. Now divide both answers. So second answer upon first answer. One will cancel, one will cancel. So dy by dx. Okay, I wrote sec theta first. So this is your answer. Now take another derivative. So this time we have to differentiate with respect to x. And this will be u and this will be v. Two terms are there. Okay, so these are two terms. u into v formula. So take this at a time, then differentiate, and this into derivative of this, and then extra d theta upon dx. So now after this I have to differentiate it with respect to x. Now this will be d square y. 3 is outside. Okay, because 3 will belong to both the terms. So now I write first sec theta as it is. Okay, u into derivative of v. So derivative of tan theta is how much? Sec square theta plus v into derivative of sec theta. It is nothing but sec theta tan theta into extra, don't forget this, d theta upon dx. Okay, so that is d theta upon dx. There's slightly light which is falling on the side, so it's little light. Okay, this is d theta upon dx. So substitute the value of d theta upon dx. From that, dx upon d theta, make it ulta. And what is common between both the terms? Sec theta is common, so you can remove out sec theta. So sec theta, I'm taking out common from both the terms. So only sec square theta will remain, and here tan theta into tan theta will be tan square theta into 1 upon. Okay, so what was d theta upon dx? So that was sec theta tan theta, I think. Okay, now this one will cancel. Okay, so answer what you will get is 3 sec square theta plus tan square theta upon a tan theta. Okay, this is the answer. And now at theta is equal to pi by 4 they have said. So everywhere pi by 4 and find the values. So sec 45 is root 2 and there's a whole square. Tan 45 is 1. Same way tan pi by 1. Okay, so this will be 3. I told you cos 45 is 1 upon root 2. So ulta sec 45 will be root 2. This is square, so don't forget to square it. If this was cube, this would be cube. Plus, anyways, 1045 is 1. You don't have to worry about that. A into 1. And now, root 2 square will become 2. So 3 into 5 will be 9 by A will be your answer. Now we have finished. You can try this. If x is equal to 1 minus t square, 1 plus t square, y is equal to 2t upon 1 plus t square. Find d square y upon dx square at t is equal to 2. This is all t, 1 minus t square upon 1 plus t square. This is 2t upon 1 plus t square. So take this will be u upon v formula. X is equal to, so we have to differentiate with respect to t. So dx upon dt, u upon v. So what is the formula? V into derivative of u. Please put brackets. This is whole v into derivative of this. So it will be, okay, middle sign is minus. Now u, again bracket, into derivative of v upon v square. If some of the students don't even know this formula, means you are not even knowing 1% of derivatives and you're completely lost. Okay, so this is v into derivative of u minus u into derivative of v upon v square. Then simplify. So minus 0 minus 2t is anyways minus 2t. So it will get multiplied to both the terms. So minus 2t minus 2t square cube it will become, no? T square into this. Then now minus, see this is minus 2t. So minus 2t, again minus into minus will give me plus 2t cube. Okay, so minus will belong to both the terms. Upon. So if you don't put brackets and on, this minus will belong only to this and this you will make minus. It will be wrong. So please put brackets while solving. So this is answer of dx upon dt. So same way find dy by dt using u upon v formula. So y is 2t. So dy upon dt. This all right, I differentiate with respect to x t. So v into derivative of u. 2 is anyways coefficient. Derivative of 2t will be 1. You can directly write it as 2 also. Minus v into derivative of u upon v square. Two will get multiplied to both the terms. Minus into plus will give minus 4t square upon 1 plus t square the whole square. Both of these terms are same. So 2 minus 4 will give you minus 2. So you will get like this. Okay, there's a square here. Huh? So this will be a dy upon dt. If you want, you can take out 2 common. So what you will get is 1 minus t square. And now divide both the answers and find dy by dx. First y answer upon x answer. How much was that? Minus 4t upon 1 plus t square the whole square. Alternate you can cancel. Okay, so this is alternate. 2 and 4 will cancel. So answer will be upon minus 2t. Okay, so this is your v. Now differentiate with respect to x. So this will be d square y upon dx square, which will be equal to v into derivative of u. Again, you have to find the derivative. So upon v form, v is minus 2t into derivative of this. Middle sign is minus into derivative of minus 2t will be minus 2. upon v square. And then open up the bracket, simplify and put t is equal to 2. Because in the question it has been asked find d square y upon dx square at t is equal to 2. Minus into minus will become plus. Again minus into minus, so it will be 4t square. Minus into minus is plus 2. To solve, we'll get like this. Square will belong to both the terms. Like this you will get the answer. 4t square minus 2t square. Extra this forgot. Nobody reminded also. dt upon dx. Theta correct. This is t. Extra dt upon dx has to be written. Okay, so dx upon dt was how much? Minus 4t upon 1 plus t square the whole square. Now this will become ulta, reverse. So this will be if you forget this, the whole problem will go wrong. dt upon dx extra, okay? Four minus 2 will give you 2t square plus 2. Okay, upon 1 plus t square the whole square upon minus 4t. 2 if you take out common, so this will be t square plus 1 into, again I am writing this ulta, 4 into 4 will give you minus 16 t cube. 8. If you want, you can directly put value of 2 over here also, but actually standard way, if they had not asked you, okay, at 2, if they had just asked you find d square y upon dx square, you cannot leave the problem here only. Okay, but if in case they ask you find a value at t is equal to 2, without actually trying to simplify also, if you try to put directly t is equal to 2, you will get the same answer. Okay, but better simplify it first and then substitute. It will look decent. In case you don't want to take the risk, you can substitute here. So t square plus 1 into square will give you t square plus 1 the whole cube upon. So this is your actual answer. And now put value of t is equal to 2. How much you are getting? Anyone has found out? Put value of t as 2 and tell me the answer what you are getting. Wherever there is t, put 2 and solve.
Minus 27 by 8.
How much?
Minus 27 by 8.
I'm not able to hear you. You just type and otherwise. Those others also, those who have got the answer can tell, doesn't matter. You can at least give a try, whether correct, wrong. Nobody got the answer still? Oh, wait, someone has messaged. Minus 27 upon 8. I'm not sure. Let's see. Still something. Minus 27 is not correct. Again, even that minus 125 upon still something. Denominator, I made a mistake, I think.
The 64. Minus
Upon,
1 upon 64.
yes, upon 64 is the answer. See, you all have done some mistake while simplifying. You are still struggling with Bodmas rule, huh? That bracket first, then addition first, squaring first. Just see. 2 square plus 1, the whole cube, upon minus 8, 2 cube. So 2 square is 4. 4 plus 1 will give you 5 cube upon minus 8. 2 cube is 2 into 2 into 2. That will be 8. So 5 cube is 125 upon minus 64. You are trying this. X is equal to e raised to t sin t minus cos t. Y is equal to e raised to t sin t plus cos t. Find d square y upon dx square at t is equal to pi by 4. X is equal to e raised to t sin t minus cos t. Y is equal to e raised to t sin t plus cos t. Find d square y upon dx square at t is equal to pi by 4. This is t. So you can start differentiating. This is u, and this is v. It will be u the v rule. Okay, u is e raised to t, and v is this. So first, u into derivative of v plus v into derivative of u. So differentiate with respect to t. So dx upon dt will be u into derivative of this. So sine t will be cos t. Already minus is there. Derivative of cos t is, you can directly write plus also. Derivative of cos will be minus sine t. Okay, so dx upon dt is e raised to t cos t plus sine t plus this v into derivative of u. Later this part I'm not. Sine t minus cos t, derivative of e raised to t will be e raised to t only. Okay, u into derivative of v plus v into derivative of u. And now open up the bracket. So this will be e raised to t cos t, minus into minus is plus. So cos and cos term will cancel. So this is the answer we will get. Same way, solve dy by dt. Y is e raised to t sin t plus cos t. So dy upon dt will be e raised to t v into derivative u into derivative of v. So cos t minus sin t plus v into derivative of u. Okay. Again open up the bracket and cancel whatever is getting cancelled. Plus e raised to t sin t e raised to t cos t. Sin and sin will cancel. Same terms. So 1 plus 1 will give you 2 e raised to t cos t. And then divide both the answers. So dy upon dx will be 2 will cancel. Answer will be cot t. Now differentiate with respect to x. So what will happen? Derivative of cot t will be minus cos x square t into extra dt upon dx. And then substitute the value of dt upon dx. Make dx upon dt ulta and the right. When you differentiate, this is always fixed with respect to x. So derivative of cot is cos x square t and x not matching, so extra dt upon dx. Even if you forget something, what is it? Like if you are confused, is it dx upon dt or dt upon dx? What you can do, just look at the first equation. It is always dx upon dt when you are differentiated. So you know that you have to get ulta of this. So looking at the first equation, just make it reverse and write. Even if you forget that, answer directly can reverse and substitute. Minus is there, no? So this will be minus cos x square t into dt upon dx. So that will be 1 upon okay. So either you can take sine on top and make it cos x cube t, or you can bring cos x square down and make it sine square. So if you bring it, it will become, so this will be your answer. E raised to t is there, no? Cos x square, I brought it to the denominator, it will become sine square t. And sine square t into 1 more sine t will give you cube. Those who want can write it the other way also. Sine you can take up and make it cos x cube t. At pi by 4. So that will be e raised to pi by 4. This will remain like this only. Sine cube pi by 4 into sine cube will be 1 upon root 2, the whole cube. Sine 45 is 1 upon root 2. This is cube, means this will be cube. Okay. So cube will be both the terms. So 3 times root 2 into root 2. So this will give 2 root 2. And then this will reverse. So answer is root 2 okay upon e raised to pi by 4. Next question. If x is equal to a cos cube t, y is equal to b sin cube t, show that at t is equal to whenever they give, show that this is the answer, it's always good, because you know that in case you solve and if you're getting the answer, it is 100% correct. So you can start differentiating. Find dx upon dt, then find dy by dt, find dy by dx. So dx upon dt will be a, this is cube. So cube, so this will be 3 cos square t, okay, into derivative of cos t will be, so this will be dx upon dt minus 3a sin t cos square t. I just arrange this. Minus I brought first, sin t I wrote first. Whichever we write doesn't matter. Okay, so this is dx upon dt. Same way find dy upon dt. So dy by dt will be b. First, this will be 3 sin square t into extra derivative of sin t will be cos t. So this answer will be 3b sin square t cos t. And then divide both the answers. And then you will get dy. So this is t. So find dy by dx. Second answer upon first answer. So dy 3b sin square t upon minus 3a sin t cos square t. 3 cancels. 1 square, 1 sin will go. Okay, so sin upon cos will remain. So answer will be. So if you have got this answer, good enough. Okay, then differentiate with respect to x. So this will be d square y b minus b upon is the coefficient. So derivative of tan of t will be x square t into extra dt upon dx. Okay, then reverse dx upon dt answer and substitute here. Still, if anybody has a doubt of this, please ask. This is fixed, that extra you have to write dt upon dx because d and x are not matching, and this answer you have to get from dx upon dt. Whatever is the answer, make it ulta and substitute. You can write like this. Okay. So sec square, if you bring down, it will become cos square. Square and square will give you 4. So minus will cancel. So b upon a into a will give you a square. Sec square I'll bring down, so it will become cos square. Already square and square will become 4. Okay. Or if you want, you can write the other way around. If you would write like this, it will become sec 40 into cosec t. This or this. Both the ways answer is correct. And then put t is equal to pi by 4. Okay, put the value of t as pi by 4. And then I think you should get the answer. Sec of pi by 4 is root 2. Same way this is also root 2. Okay, so this will be root 2 raised to 4. So 4 times if you multiply like this, so this will give you 2, this will give you 2. Okay, 2 into 2, and then this will give you 4. So that's the answer. 4 to b upon 3a square. Okay, so we will stop here. Just take the attendance.